What's up, everybody? My name is Jake Itel. This is my presentation on my individual assignment for Engineering 107, Section 10. So I want to introduce you to everybody who helped work on this robot. Obviously, myself, Jake Itel. I'm a second-year electrical engineering student at Grand Valley, and funny fact is I slipped on ketchup on the kitchen floor and absolutely biffed it. And this led to inspiration for the robot that I'm building. On the right side, we have my roommate, Megan Walters. She is a registered nurse at the GVSU Campus Health Center. She has absolutely nothing to do with engineering, nor does she know how Arduino works, but she hot glued everything for me, so I feel like she deserved a placement on my team. And funny fact, she was the one that spilled the ketchup that I absolutely biffed it on, so we can thank her for the inspiration for this project. Alright, so a little bit about this project. I built this for a couple of different reasons. My main reason was to cater to busy people like myself. I'm a college student. I don't have time to sit down every day and scrub my kitchen floor. That also leads me on to my second point. Manual labor sucks. I don't know if you guys have ever tried to scrub your kitchen floor by hand, but it is an absolute pain in the butt. The traditional autonomous cleaners, most of you probably know them as like the Roomba, are ridiculously expensive. And again, being a college student, I'm broke and I cannot afford a $500 floor cleaner. So that's kind of why I built this, was to cut the price down for the same product. And nowadays, I mean, everything is hands-free, so it should only make sense that your cleaning is hands-free. So I introduce you the Set It and Let It mop, also known as the SLAM, or the Set, Let, and Mop. So a little bit about this: it's a completely autonomous floor cleaner. All you have to do is plug it in and it'll do the rest for you. It has a refillable solution reservoir. You can put water, you can put soap, whatever your desired solution is. It also provides audio and visual feedback for hands-free use. So when that reservoir is empty, it'll actually stop itself and a buzzer will go off along with a red LED will light up to let the user know that the reservoir is empty and needs to be refilled. Another thing is it's basically push and go. Other than refilling the reservoir, once you put it down, the bot's going to take care of your kitchen floor for you while you do all of your other activities, and it'll let you know when it's done or needs refilling. So a couple of the little specifications on the bot: it is powered by two 6-volt DC motors. I was originally going to use 4, but I ran into the problem of not being able to control 4 separate wheels with one H-bridge. I didn't have enough space on the underside to mount the second H-bridge like I had planned, so I had opted for a freely spinning caster wheel in the front. Up top, I've got a water moisture sensor. It detects the amount of water present on the sensor itself. When this water sensor detects that there's no water available, this is going to turn on an LED and a buzzer to let the user know. Inside the reservoir, we have a 4-volt. It's actually an aquarium pump. I was going to use a pump that I pulled out of a coffee maker, but I couldn't get that one to work. So this is what I opted for. The pump is connected to a relay, and I use this relay to flick the pump on and off. I wasn't able to control the flow rate like I had wanted to, so I figured pumping in intervals was my next best option. And then on the front here, we have a directional servo, a continuous servo with a scrubby mounted onto the bottom. This acts as the brush or the scrubber for the floor beneath, and the water comes out of a hose and it drops directly in front of the green scrubby pad. And then the whole thing itself is powered on 2 9-volt batteries. I've got one battery pack powering my H-bridge, as you can see here. And then behind these wheels, you can't really see it, there's another 9-volt that powers the Arduino and all of the electrical components, such as the ultrasonic sensor that I have here in the front, the servo, the relay, and everything else that's not connected to the H-motor, the H-bridge. Alright, so as far as empathizing, I kind of touched on this in the beginning in the first or second slide, but my main reason for building this robot was because of the price tag on traditional autonomous cleaners. Roomba is one of the more popular ones. They're also one of the more expensive ones. I did a little bit of research just to see how much they were, and I think the cheapest I found was like $300, $350 for some of the nicer end cleaners. And that's obviously not in my price range right now. Like I said, I'm a college student, I'm broke, and I can't afford to fish out $400 on an autonomous cleaner. And as far as scheduling goes, like I said, I'm busy as well. I have a part-time job and I'm a full-time student in school. So it's very rare that I have time to get on my hands and knees like my mother would want me to and scrub the kitchen floor. A lot of people would argue that you could use a vacuum to clean your kitchen floor, and I would have to agree with this. We actually have a vacuum with a hardwood floor option. However, this is very good at picking up, debris and crumbs on the floor, but this doesn't take care of stains or like liquid spills. And that's where my rip-off Roomba excels. And let's be real, hardwood floors are in. Everybody has them, and everybody is going to need a solution for cleaning their hardwood floors. So a little bit of inspiration behind this project. I actually slipped and fell on a pile of ketchup in our kitchen floor. Thank you to my lovely roommate. I had to get on my hands and knees and scrub, which sucked. And while doing this, I thought, I could build something that would clean my floor while I do my homework or while I study or while I'm not gone. Because quite frankly, I'm busy. I'm a college student. I have a job, like I said before. And, I just don't have the time to clean my kitchen floor. And Michael Reeves was actually another big inspiration to this project. For all of you who don't know who he is a YouTuber. He makes ridiculous inventions with Arduino and whatnot. In the top right corner, I actually linked a video of his. He turned a 3D printer into a giant spike that picks out tomatoes out of his salad because tomatoes are gross. But yeah, he gave me a little bit of inspiration. I liked his crazy ideas, and I thought, if he could do it, I could do it. So I definitely referenced a couple of his videos for some crazy ideas, and out came the final product. And for the problem statement, what I'm trying to tackle with this creation is the problem of having a clean floor while still maintaining your busy schedule at a cost much cheaper than traditional autonomous floor cleaners. Alright, so for defining, we have a couple of requirements. The biggest overarching requirement was to obviously clean the floor. You can't have an autonomous floor cleaner if it doesn't clean the floor. Another requirement was, of course, for it to move so it could navigate around obstacles and clean the entire surface. It should also provide sensor output via visual and audio feedback. To do this, I used a little buzzer and a red LED light to let you know when the reservoir is empty. It should also remain hands-free. It should not require any user input apart from putting water into the reservoir and turning it off and on as needed. It should also cater to all types of hard floor surfaces such as linoleum or hardwood flooring. The scrubby on the bottom should not be abrasive, and it shouldn't do any damage to a different type of floor. So you should be able to pick this bot up and move it to a different spot and have no problem. As far as constraints go, cost was my biggest one. With this, I wanted to stay under $50. I think I ended up spending about $47 total. And this was primarily to beat the price tag on a Roomba. And the $50 also included the price of tools and materials used to assemble the robot, such as hand drills and adhesives, so we were able to keep it pretty low. As far as ease of use, like I said earlier, the bot should have an on-off switch. In this case, it was plugging in the power pack. Other than that, the user should not have to do anything other than fill it up and turn it off. The size, I originally wanted to keep this under 6 inches to allow it to go under tight squeeze areas. This didn't end up happening, so I revised my constraint. So instead of a 5-inch bot, I went with 7.5. That was actually the lowest I could get it. And that is to just so it was able to navigate like under chairs. Power consumption, this one completely failed as well. I was originally planning on powering the entire thing off one 9-volt power source. This proved to be not possible in any way, shape, or form. So I ended up powering the H-bridge and the motors with its own 9-volt battery, and then I used another 9-volt battery pack to power all of the Arduino components that weren't connected to the H-bridge. And as far as critical functions go, the overarching one here again is scrubbing the floor. Obviously, it's a floor cleaner, so it should clean the floor beneath it. It should be able to autonomously detect obstacles, and we did that with the ultrasonic sensor. It should also be able to detect when the reservoir water level is low or getting low. This will stop the pump from burning out from pumping nothing, and this will also let the user know that the robot is out of water and it needs to be filled up. And finally, it needs to dispense solution or water or whatever you decide to put into the reservoir in order to clean the floor. Alright, so time for the fun part. So on the left and right side, I have two of my original concept designs. Neither one of these actually won for my final design for a couple of reasons. The one on the left side, I had originally planned on using 4 wheels as opposed to 2 in my final design. However, I wasn't able to get a H-bridge to power 4 wheels simultaneously. So I was originally going to opt for the Concept 2 that I have here on the right side to get past the problem of using 2 wheels or 4 wheels. And another problem I ran into with Concept 2 was the fact that if I put a ball bearing down on the front of the chassis, I wouldn't have room for a servo. So what I was going to do is mount the servo on top of the chassis and have the axle running through the chassis. However, there wasn't enough space once I added all the components in the reservoir to the top of my chassis, so I had to skip out on design 2. Couple differences between these two. The Concept 2 doesn't use a pump. I was going to use the ball bearing to gravity feed the solution out of the water bottle. This obviously wasn't very logical because mixing electronics with water isn't a good idea, and I figured having a gravity-fed system could in turn start leaking through the top, and I didn't want to fry my board on the very last day. So a couple of different ideas that I was toying around with while planning this. As far as scrubbing the floor, there was really no competition here. I opted for the scrubby because I figured it was going to provide the most results as opposed to a hanging cloth, and a vacuum just didn't seem reasonable because I wasn't able to fit it onto my chassis, or nor did I have enough pins on the Arduino. As far as obstacle detection, I was kind of weary on using the ultrasonic sensor. We used it on our bot, and it worked sometimes, but not as well as I would liked. I was going to use limit switches, however, I wasn't able to get them in the mail in time, so I was stuck with using the ultrasonic sensor. If you look at Concept 2, I actually have limit switches on the front and back as opposed to the servo or the ultrasonic sensor mounted on the top. And then for reservoir detection, this was kind of a no-brainer too. My only choice here was a water sensor. I thought about using the ultrasonic sensor to gauge how much water was in there, but we actually used this for our ball detection on our bot, and it didn't prove to work very well, so I figured the water sensor was the only logical solution here. Dispensing solution, it was either going to be pump or gravity fed. I opted for the pump just because it was a little easier with my design and space. And then for movement, like I said, I originally wanted to use 4 wheels. However, that didn't work because I wasn't able to power all 4 wheels on one H-bridge. And then my second option was going to be ball bearings, but like I said, that didn't work because I wasn't able to fit the servo. And then tracks, that was for if I had more time than I would have liked. Alright, and then this is actually the design that I went to. I didn't come up with this design until after my pre-planning. So this one is a little different from the original two. They all have the same features and the same sensors, like the ultrasonic, the pump, the water sensor, the H-bridge and whatnot. However, this uses 2 wheels and a caster wheel. I chose this option just because it was a little easier to get the servo mounted underneath, because with the caster wheel, it popped the front end up enough that I was able to get the servo underneath. And this also helped me combat using only 2 wheels as opposed to 4. This caster on the front is completely free spinning, so that it's two-wheel drive in the back as opposed to four-wheel. Alright, so quick look at my pre-build, or in this case it was kind of my prototype. I didn't actually do a separate prototype. I wasn't able to find enough material. I was going to use cardboard to make like a rough sketch of what it should look like, but I wasn't even able to find enough cardboard in the house. So what I did is I pieced it together one by one, and I tested at each stage. So first here, I tested with just the motors and the caster. All this was to do was kind of check my speed to make sure the wheels were spinning properly and that this was going in a straight line. And I also wanted to see how this caster would affect the weight, because this front caster is pretty heavy compared to the back, but once we threw the battery pack on the back of the bot, it kind of leveled it out, and the back wheels got a little more traction. And then here's a top picture of my chassis. There's not much going on here yet. But this is where things started to get really messy. I wired up the relay here on the left side, and then I also wired the H-bridge to the Arduino. I also included the ultrasonic sensor at this point. This portion of the testing was checking my obstacle detection and fine-tuning the values. And once we got all that down, I went ahead and installed the pump, the reservoir, and the water sensor that you can see sticking out of the top here. And as you can see, things got extremely messy, extremely quick. Yeah, and so that was kind of my prototyping. I just took it piece by piece, and I tested at each stage, and I fine-tuned everything that needed to be done at each stage before I added in the next component. The only thing that's missing here is the servo that was going to be on the front. I actually ran into a problem with this, which I will touch on later in the reflection. But there is a reason that the servo wasn't included in this picture yet. And then in the final design, I also added a little popsicle stick holder for the tube. All that did was kind of extend the hose out and make sure that it secured it down so it didn't spray willy-nilly.
Eyes in the sky, gazing far into the night. I raise my hand to the fire, but it's no use, 'cause you can't stop it from shining through. It's true, baby, let the light shine through. If you believe it's true, baby, won't you let the light shine through for you.
Alright, so there was ups and downs with this project. I had a lot of fun building it. It was also a pain in the butt in many different ways, but in the end it worked, and that's what I'm happy about. One thing I learned that I had absolutely no idea was even a thing was the fact that servos take pins 9 and 10 in the library. I probably spent 3 or 4 hours unplugging and plugging pins in, trying to figure out why I couldn't get my motors to move. I actually had my Enable A and Enable B on pins 9 and 10, and I could not figure out for the life of me why once I added the servo library in, the motors would just stop moving. I think I found the solution on like page 6 of Google. I got really, really lucky. I found a forum post that said the servo library uses the timer 1, which I'm not too familiar with what that is exactly, but they take pins 9 and 10. Once I unplugged those and put those into different pins, it worked completely fine. And this was something that I had absolutely no idea about, and it was super pain in the butt because I spent hours and hours and hours trying to figure out what was wrong, and it was a simple little solution. Schematics, that was a big one. I actually didn't make any schematics going into this. I kind of did it all on the fly. I got extremely lucky. I actually used every single pin on my Arduino. If I had included one more component, I wouldn't have had any room on my Arduino, so I'm really lucky that it worked out the way it did. This is something that would have been easily avoidable if I would have had made schematics and planned out my wiring a little bit first. And that kind of goes with pre-planning too. I originally wanted to make this robot a little cleaner than what it is now. You can see in the first couple of pictures on the slide that I showed that it was pretty neat and cable managed in the beginning. But once I started wiring things up, like the H-bridge and the relay, things got out of hand really quick. And I kept telling myself, oh, I'll cable manage it once I have all the wires in, because I don't want to zip tie one singular wire. I'll just wire them all together. Once I got all the components in, there was wires running in every which direction. I actually had a couple times where I got snagged in the wheel and completely ripped the Arduino board off. And then time allotment. I kind of took for granted the fact that in our robot group, our original Robosaki group, we had a repeat 107 student, and he knew exactly what worked and what didn't work, so our bot worked pretty much the first time around, and I kind of figured I could do the same with my bot. However, this didn't really prove to be the case. I thought that I would just be able to do it on the fly and go as I went. You know, I had a little bit of pre-planning. I had a general idea of what I wanted to get done, but I feel like a little more research would have helped me a lot in terms of time allotment. I spent a good chunk of my weekend working on only trying to get the motors to move. I think I probably could have had the motors done in a couple of hours had I known the problems that I was going to be facing. Whoops. And other than that, it was a very fun project. I'm happy with the results. I wish that I would have done things a little bit differently and cleaned it up a little bit more, but for the resources that I had and the situation we're all in, I'm pretty happy with how it came out. And I'm actually considering building upon it and making it a little bit better, just as like a little side project, but I think I'll save that one for a rainy day.